Hi guys, we're going to do two variable linear inequalities here. I made this Google slideshow last week, so let's see if I remember what I put in here because I didn't make the video yet. But hopefully we'll just make limited mistakes on this as we go. Okay, so here's a little review. So you have this equation for a line and they want to know which of these points are on the line. So how can we figure that out? It won't really help us to get y by itself here. Getting this in slope-intercept form is not what we really necessarily want to do. But instead, what we're going to do is we're going to start plugging in points for x and y. And if it's on the line, it would be a true statement. And if it's not on the line, it would be a false statement. So if I plug in -3 for x, so 5 times -3 plus 10 times 0, does that equal 15? Well, it's -15. So no, -15 does not equal 15. This is not on the line. How about -1, 2? 5 times -1 plus 10 times 2, does that equal 15? You have a -5 and a 20. That gives you 15. This guy is on the line. How about 1, -2? Well, that'd be 5 times 1 plus 10 times -2. 5 minus 20, that would be -15. Nope, not on the line. Now 0, 3, if you wanted to, you could get y by itself here because this is going to be the y-intercept. But let's go ahead and just plug it in. That would be a better way to do it. 5 times 0 is 0. 10 times 3, that's 30. That's not 15. So only one of those points is on the line, and that's the second one. Now, technically, they all could have been on there because there are infinitely many points on that line, so you should have checked them all. Okay, what else can you tell me about the line? Well, we could find the x and y intercepts if you want. We could say x equals 0 means that's the y-intercept. And if x equals 0, 10y would be 15. Divide by 10. They have a 5 in common. So 3 halves, or 1.5, would be the y-intercept. You could tell me the x-intercept by making y equals 0. Y equals 0, we're going to have 3 for x because 5x is 15. So you could say the point 30 is the x-intercept. You could tell me the point 0, 3 has is the y-intercept. We could find the slope. We could get y by itself and find the slope. 10y is -5x plus 15. I went ahead and did the first step by subtracting 5x. Divide all the friends by 10. And you get y is -1/2 x plus 3 over 2. So the slope would be -1/2. So there's lots of things you could tell me about the line if you needed to. And now we're going to talk about what we're kind of looking at today. So let's say that a band charges $150 per weekend show, and Y is the number of weekend shows they're going to do, and they want to make at least $900. How many shows are we looking at here? At least, okay? So they can make more than this. So this is not an equality. This is an inequality because they can make more. So if you take 150 times the number of shows, they want that amount to be greater than or equal to 900. So 150 times the amount, they want this to be at least 900. So they want this to be greater than or equal to. And we did problems like this in chapter 1. You can divide by 150 and y would be greater than equal to. 900 divided by 150 is 6. So y is greater than equal to 6. And then we would graph this and we would put 6 on the number line in a solid dot and we would shade to the right. Now you would keep in mind, because it's the word problem, 6.2 doesn't mean anything here. You're 6, 7, 8. You're looking at, oh, that's a 9 next. You're looking at integers that are, greater than 6, but you can't have rational numbers in between there. So to make at least $900, they have to do at least 6 shows. So that is a one variable inequality. We're going to be talking about two variable inequalities today. So that's the objective. We're going to talk about two quantities and we're going to discuss what that means. So what if there were two unknowns? So this time they're going to say, so it's 150 for a weekend show, but only 50 for a weekday show. And they want to earn more than 1,500. So what we're going to do is you're going to do 150 times x, because that is the weekend show apparently. And you're going to add 50 times y for the weekday show. And they want it to be greater than 1,500 because they want to earn more than 1,500, not at least. They want more than 1,500, so they did a greater than sign this time. So what would we do here? Well, if they wanted to make exactly 1,500, you would have 150x plus 50y equals 1,500. If you want to make more than that, we had the 150x plus 50y is greater than 1,500. So which expression represents the revenue from performing X weekday shows and Y weekend shows? Just the expression is 150X plus 50Y. That's an expression, no equal sign. Exactly is an equation. And this guy is the inequality. Now, when we're looking at all the possible combinations here, we can graph this. We're going to graph the boundary line, and then we're going to consider where the solution would fall. Okay, so we didn't look at that yet, I suppose. This one's different. And they're switching up X and Y, it looks like. Okay, so let's finish this up, and I'm going to show you what this graph will look like. And I may be doing a little bit extra here, but that's okay. Cover this up. Okay, so let's get Y by itself on the boundary line first, okay, because that will be our boundary. And we'll have 50y equals negative 150x plus 1,500. And you'll divide everybody by 50. And you'll get y is negative 3x plus, zeros will go away, 150 divided by 5 is 30. So this is the boundary line, y equals negative 3x plus 30. Now, you can't have negative shows, so we're really only dealing with quadrant 1 here. And if you go up 30, let's count by, I'm going to count by threes actually, just to make my life easier. 3, 6, 9, 12, 15, 18, 21, 24, 7, and 30, okay? And the slope is negative 3. I'm going to go down 3 over 1. Well, if I go by threes here too, if I go down 3 over 1, that's the same as going down 9 over 3. Okay, so it kind of looks like this, and mine might be kind of bad here. I don't know if I did that right or not. Okay, so that is the boundary line, and I didn't do very good because I made a solid line. First of all, it's really garbagey looking, so you got that. But I should have made a dotted line because it cannot equal that number because we need to make more money than that. Okay, so we need to make more money for that. So where are the values more than where it equals? Here's where it equals. Well, it's more up above. So all of these are the solutions that would make me more than $1,500. Okay, if you picked a number here like 3 weekend shows and 3 weekday shows, or 3 weekend shows and 3 weekday and 12 weekend, these will not get me enough money. These will get me enough money up here. And they don't do a lot of graphing, shockingly, in the lesson itself. I think we're doing more with the equations, but that's kind of what we're looking at today. Now, what would have happened if you would have switched your X and Y so that, is this the same thing we had? 50X plus 150Y? No. Okay, so I don't know if I switched or they switched, but I'm a little confused at the second. So we're going to look at this one now. This time, X is the weekday. And if it was before and I jumped in the middle, I apologize. And Y is the weekend. okay, because of the price. They want to know if they play 6 weekday and 5 weekend, do they meet their goal? Well, let's just check. First of all, it would be in the region if you graphed, but I don't think I graphed the correct problem. So we'll just plug it in. So if you take 50 times 6 plus 150 times y, which will be 5, is that going to be greater than 1500? Well, 50 times 6 is 300 plus 150 times 5, that's 750. That's not enough money. No, that's 1,050, and that's not bigger than 1,500. So they do not meet their goal. It is not in the solution set. The solution set would have been all those above the line. Okay, so here we have 50x plus 150y. If the band plays 15 weekday shows and 6 weekend shows, will they exceed their goal? Well, let's see. And by how much? Well, if you have 50 times 15 plus 150 times 6, let's see if that's enough. Well, 50 times 15 is 750 plus 150 times 6 is 900. 900 plus 750, that gives me 1650. So did they meet their goal? Yeah, they did. They met their goal. And they actually exceed it. How much do they exceed it by? The goal was 1500. 1500, so 1650 minus 1500 would be $150. They exceeded it by $150. Okay, so now let's see all these solutions. Okay, I am going to go ahead and graph it so that you can understand this graphing a little bit better, especially since I think I did it wrong the last time. So let's look here. Let's get y by itself. And I have 150y greater than negative 50x plus 1500. Divide everybody by 150. And I get y is greater than negative 50 divided by 150 is just negative 1/3 x plus cancels. 150 divided by 15 is just 10. So if I graph it, and we're looking at quadrant 1 for the reasons I said, this is a little easier to graph. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we're going to go down 1 over 3. Okay, and I'm going to end up all the way over here if I keep going down 1 over 3, all the way at 30. This will be a dashed line. And we're looking to make more than that, so these are all the values. So they want to know if these order pairs are in the solution set. Well, is 1 10 in the solution set? Yeah, if you go over 1 up 10, that is in the solution set. And you can check it by plugging it in. That would be 50, 1 plus 150 times 10. And the 150 times 10 is actually almost enough, except you need to be greater than that. So that will get me, that'll be 50 plus 1500, and I exceed by $50. That is in the solution set, and you can tell that it's in the shaded region. Now, what if you have 10 for x and 1 for y? You can tell that's not in the solution set. It's going to be over here because 50 times 10 plus 150 times 1 is not enough money. That's 500 plus 150. That's not enough by a long shot. How about 0, 10? 0, 10 is on the line, but my line was dotted. So it's not enough money because 150 times 10 is not greater than 1500. It's equal. So it does not work. And how about 50 times 40 plus 150 times 0? Well, what is 50 times 40? It's 2000, and that would be enough. And if you went over 40, 0, it would be in that shaded region where all the solution sets lie. Okay, so another practice problem here. The band's manager earns a monthly rate plus $20 for each show. That sounds like a rate of change for me. And there is a constant rate somehow. So we need to figure out what's going on here. X is the number of gigs they book, and Y is the monthly rate. So write an inequality that relates the manager's number of gigs and the monthly rate to last month's earnings. Okay, so last month they made $170. So they make $20 per gig. So 170 equals 20 per gig, which is X, plus the monthly rate. Now that Y is not changing. I probably would have just found the initial condition if I could, but it doesn't look like they give me enough. So this is going to be the equation. And they want it to be an inequality. They learned at least 170. So 170 is less than or equal to 20x plus y. Then equal it was less than or equal because they want this amount to be more than this amount. The ordered pair is not a reasonable solution to this inequality. How come? Well, no, of course not. 0, 0 will not work. First, it won't be in the shaded region, but let's think why. That would be 0 gigs and a 0 monthly rate. You're not going to make $170 if you don't work. So that is why it is not reasonable. Okay, if you're going to graph y is less than -1, you put -1 on your number line. You'll do an open circle, and you will shade to the left. All of these are values that are less than -1. You can also graph that on the coordinate plane. Y is -1 would be your boundary line. Y equals -1 right here, and it will be a dashed line because it cannot equal -1. Where is y less than -1? This is all this area down here. All of these ordered pairs have y values that is less than -1, even really close. But once you get to the line, then it equals -1, and that is why it is dashed. This is a two-variable linear inequality. If you get y by itself, it would be y is less than or equal to -2x plus 4. Don't forget, if you would have had to divide by a negative, you would have had to flip the inequality sign, but instead I just subtracted, so it's fine. So I'm going to graph the boundary line. I'm going to do a solid line this time. So I went up 4, down 2, over 1 for a slope, and it's a solid line. Then you have to ask yourself, where is y less than that line? It's less than that line when it's below the line or lower. If you get tricked up on the lower and above, you can also pick what we call is a test point to see. If you plug in 0, 0, your 0 is less than 4. If 0 is in the solution set, then this is called the half plane that you will shade. If 0, 0 was false, then you would have shaded the other side. So which one of these is the solution set to 50x plus 150y is greater than 1500? Okay, first of all, it's a greater than sign, so it has to be dashed, so these guys are out. If you get y by itself, you'd have 150y greater than -50x plus 1500. If you divide everybody by 150, it's the equation we talked about earlier. Both of these have the correct graph. One of them is shaded in the wrong spot. So really, you need to decide, is 0, 0 a solution or not? Well, is 0 greater than 1500? No, it should not be in that region. So it should be a region above it where they make more money, or it's greater than the line, above the line. A band charges $150 per weekend show and $50 per weekday show. The band needs to generate more than $1,500 revenue. More of the same example. Here's the graph. It says they needed to grab more than 1,500, so the graph is bad. It should have been a dotted line, and they did not do a dotted line, but they should have. Otherwise, it would have said at least. And we're going to use the graph to answer which ones are solutions. So is 6, 2 in that region? Well, it's kind of hard to tell what my scale is here. If you can't tell, you can plug it in, but look, 5, what are we going by? 1, 2, 3, we're going by 8s. So you're going by 8s here. So 6, 2 would be like in here. And is that part of the region? No, it's not. Otherwise, you would have to do 150. 50 for the weekday, we said. Say, what was the x and y defined? This is my whole problem that I've been having today. What was my x and y? 50x plus 150y. All right, 50x plus 150y. It should be greater than 1,500. We said 6, 2 doesn't work because if you have 6 in there, it'd be 50 times 6 plus 150 times 2. That's not enough money. Is 10, 0 enough money? 10, 0 is not going to be enough money. That would be 50 times 10 plus 0, not enough. 9, 9 would be 50 times 9 plus 150 times 9. Is that enough money? Well, 150 times 9 is 1350. 50 times 9 is 450. That will be enough money. 9, 9 would be in the region. We're going by 8, so it'd be like right about here, and that is in the region. If you had 2 weekday shows, that would be X, and 10 weekend shows. 10 times 150 is enough. Over 2, up 10, it is in the region. This also works. How about 10 weekday shows? Going by 8s, and 2 weekend shows, that's not enough, or you can plug it in. So it can be in the shaded region, or you can plug it in. The band schedules 6 weekend shows, so that's Y, and needs to perform enough weekday shows to make more than 1,500. So how can I fix this? Well, if Y is 6, I'm going to plug it in. 50X plus 150 times 6 has to be greater than 1,500. So 50X plus 150 times 6, that's 900, has to be greater than 1,500. 1,500 minus 900 is 600. 50X is greater than 600. If you divide by 50, you get 12. So X has to be bigger than 12. So what does that mean? They have to perform more than 12 weekday shows in order to meet their limit. Okay, here's just a reminder of all the things we talked about. You can use substitution to graph. If you graph with a boundary line, you're going to get a half plane for the solution set. Half of it will be the answers and half of it won't. To write the equations, this is what you'll do. You can test the point to figure out where to shade. And that's it.